Hello everyone, in this video I'm going to show you how to estimate a simple panel model in Stata. So the data set that we are using is the fatality rate, which is the number of deaths on the US highways for 48 states over the period from 1982 to 1988. And the list of variables that we have are available in this table, and our dependent variable is the MR which is the vehicle fatality rate. So this is our dependent variable, and then we can have like a list of x's or list of independent variables that we can choose from. We're focusing on the effect of beer tax on the fatality rate, and I'm going also to add some economic variables. So we have unemployment rate and we have per capita personal income. So the data set and this file are available on the course site, so you can feel free to read it in details. So the first thing that you start in the do file, of course after setting your path, we need to declare the data set. So there are different ways of estimating panel models, but just to be on the safe side, declare your dataset. Some ways does not require you to declare the dataset to be panel, but some other ways would require the declaration of the dataset. So to be on the safe side, you need to declare the dataset by telling Stata that my dataset consists of cross-section and time series. XT set, X stands for the cross-section and T stands for the time. So you're telling Stata I have a cross-section and time series data set. And you have to tell Stata what is the name of your cross-section column. So here in this example, we have it as in state. And then what is the name of your time series column? We have it here is years. Describe and summarize, to describe your data set and summarize it as we did many times before. We have another command for panel data sets that would give you more details of the data set per cross-section. So xt describe and xt summarize would give you more details on the data set per each cross-section. Okay, and then next I'm going to generate the unemployment rate, the log of unemployment rate, and then the log of per capita income. And up to here, this is just the regular regression of OLS. And if I'm using panel dataset, we call it panel OLS. So let's go ahead and run it up to here. So yeah, so let me run it up to here. And you can do the describe and summarize. Let me just focus on the regression. Okay, and as you can see here from the output, beer tax statistically significant, log of unemployment rate statistically significant, this one at the about at the 10% almost, and this one is highly statistically significant. As we can see, this is of course unexpected, so this is telling us that as the beer tax increases, the fatality rate also increases. I mean, like as the tax rate increases on the can of beer. So you'd expect as tax increase on a can of beer, this would reduces the consumption of beer tax, and this reduces the fatality rate or the deaths on the highway. So we would expect this one to have a negative effect or a negative sign. Unemployment rate is negative, telling us that the higher the unemployment rate, the lower the fatality rate. It's expected, so we have less people driving, going to work, and this reduces the density on the road. This reduces fatality rate. The log of per capita income, actually you can have two ways of thinking about it. You can think as the higher the income, people have more money and they would spend on consume more beer, and this would lead to a higher fatality rate. Or you can think of it, the higher the per capita in general, the higher the income in general, people are more educated, more aware of the risk of drinking and driving, and this would lead to a lower fatality rate. So when you try to think about the prediction of the signs before you start, this one could be positive, could be negative. We have two justifications for it. So now we can see it's negative, statistically significant. Now what we have here is these coefficients might be picking up some effects that are constant among states and not change over time, and can also be picking up things that or factors that are changing over time and are common to all states, right? So let's say the first one would be an example of culture. Anything that density on the highways, this is something that we cannot observe, something that we cannot measure. Culture we cannot measure, so we want to see whether the culture per state would have an effect on whether it's okay to drink and drive. We cannot measure it, so we need to capture it by cross-section fixed effects. We also need to try to capture anything that is changing over time and common to all states, and this would be like airbags in the cars, like say the quality of the cars, the quality of the highway, the safety laws and regarding the safety of the cars in general and how this is changing over time. So we need to be able to capture this, and in order to do that we need to add fixed effects. So in order to do that we're going to do it in three parts. The first part is to add fixed effects or entity fixed effects. I'm going to use n-1 dummies. So if I have 48 states, then we're going to be using 47 dummies. Okay, and the regression would be xi, so you need to have xi here before you add the I dot state. The I dot state is a command in Stata that would create for you the dummies per state. Okay, so let's run this regression, and as we have here, the impact of the beer tax is now negative, statistically significant. However, it's not significant for the unemployment rate, and it's not significant for per capita income. However, this is the only thing that we got, like the only coefficient that we got statistically significant, and it's statistically significant at the 5%, and it's negative as expected. If we want to check whether these are statistically significant grouped together, in other words, we want to check whether the state fixed effects are statistically significant, so we perform an F-test. And the F-test, you write like test PARM underscore capital I state star. This would mean, like, this would tell Stata, do for me an F-test on all the dummies related to all states. So this one would be like this, and this one would be telling us that we have zero probability that these coefficients are equal to zero. In other words, we have we need to have these dummies included in our regression. Next, if we do like a time effect or time fixed effects, so we add I dot year, so we're going to have a dummy for each year, and we can also perform the F-test, right? So the F-test here is going to be, is basically telling us there is, under the 10%, they are statistically significant, right? Because under the 5, you would say, you know, there is a high probability that these are equal to zero, I don't need it. But if you allow for the 10%, then you would say that there is a low probability, because this is less than the 10. There's a low probability that these are equal to zero, and then you keep them. So in practice, we use like 1%, 5%, or 10%. And it's not like we have to only use 5%. So here, for example, we're going to say that they are statistically significant under the 10%. Next, we are going to add both the state and the time fixed effects. And here, what we have is just adding the two. Okay, and then we are going to perform, you can perform an F-test on only the state fixed effects, you can perform on the time fixed effect, or can you perform on both? Usually I perform it on both, because it's kind of, since I'm adding the both then, and we already performed the previous parts telling us that we need both, so I'm going just to perform it on both. and this is confirming that we need them. There is a zero probability that these are equal to 0. Okay, all right, so this is the end of this video. I'm going to be posting for you this 2 file and the data set, and then you can try it. All right.